So, ladies and gentlemen, girls and boys, where we start. Once again, I had already started, but there was a interjection in between. So, as I elaborated earlier, the construction industry is an innovation-driven industry in which new ideas, new concepts, new methodologies, new technologies keep on coming every now and then. And these new technologies can be disseminated amongst all the ranks and ranks of the construction industry only through such type of training and workshops. So this is one kind of them. So, and the topic is construction supervision for bridge works and maintenance management. So, uh, this is a photograph of the Nampung flyover which was uh, being constructed. That photograph is here. Now let us come back directly to this. So, what is construction supervision in use? As you all know, projects are built according to the approved design and drawing. This is the objective of the construction supervision. Then project comply with the specified quality standards. There is overall safety and execution of the work. There is no adverse impact on the environment or even the social safeguard is there. Projects are completed within sanctioned budget and specified time. So there may be deadline may overshoot sometimes due to other reasons, but our effort is to keep the completion of the project within the specified deadline, within the specified budget, but budget also overshoot. So these are the main objectives. So yes, what are the documents that we need? Of course, the first one is the sanctioned, technically sanctioned DPR. We must have. Then only we know what is the drawing, what are the features there given. Then specifications for works, quality control manual, work program, working drawings and dimension levels, reinforcement drawings, bar bending schedule. Sometimes this is not provided by the department, or so sometimes it has to be done by the in-house by the construction supervision consultant or by the lower ranks of the engineering wings. So contract document, bill of quantities, sanction letter, technical note, if any. Of course, there will be a sanction letter and technical note, and survey investigation and subsoil report. This is also very important. We must have the survey investigation subsoil report, approved work methodology and method statement. So that is to be cited, even for building also, even for WRD also. So these things are must when you want. Now, when the work is survey investigation is done, DPR is prepared, DPR is getting technically sanctioned, then A is given, then after tendering is over, work is awarded, LO is given. So these things are more or less official works, except survey investigation work. But the real challenge now comes in the battlefield of engineering. That's construction. So these things may take 6 months, but the actual time taken and the real battlefield, the challenge of engineering is about construction, which may take 2 to 3 years in some of the mega projects or even 4 years. So this is a very important part. Construction supervision in construction itself is a very challenging part of the civil engineering, which we all must know what are the rules, how to handle it. So suppose you are from building codes, IRC codes for roads. So these are the IRC 5, 6, 7, 21, 78, 83, IRC SP, IS 2911, IRC 54. Then more the specifications of roads and bridges. Oh, okay. So more the specifications for roads and bridges, and this is for guidelines for quality systems of road bridges, IRC SP 47. So these are the books. And suppose you are from water sources, accordingly you should have your own codes. These things are a must because we have to remain within the framework of the rules. So it's not that we are open to traverse anywhere. We have to follow the contract rules also, odal rules also. So we have to remain within the framework of the rules formulated by the government and complete the work. So these are very important. This is one photograph of Nampung erection. Then yes. After that, work site identification. So you have to identify the work site. So suppose you have to construct a bridge. That means you cannot construct it anywhere. The specified location of the bridge. What are the coordinates? So nowadays, when the survey is done, uh, reference coordination is already given in the survey. What are the horizontal and vertical coordinates? So there will be three coordinates. One is the level, benchmark, reference pillar, and there are two coordinates, northing and southing. So that will be northing and easting. So that will be given there. So we have to establish your reference pillar there so that you can, with that reference pillar, you can locate the coordinate points of alignment as well as the location of various piers as well as the foundation coordinates. So nowadays it has become very easy. Earlier we had to do it with reference pillars. We have to fix in river bed, then we have to measure with tape. So nowadays it has become very easy to mark the alignment as well as the setting out point lines. These are it. Then apart from that, you have to finalize the, suppose it is a mega project, then you have to finalize the site for the site laboratory and batching plant, casting yard, etc. Because if the batching plant is very near to the work site, it will be very easy for transportation of concrete, placement of concrete. So if it is very near, sometimes it's not available. So we have to go for far off site. But it is finalization of the site laboratory. Now this is also very important. So we have to identify the sources of the construction materials, sources of good construction materials. So like fine aggregates, coarse aggregates, then cement, steel. So cement and steel comes in a standard form from manufactured process, but aggregates and sand, their quality keep on varying. So keep one source, prove it as per a standard specification for concrete aggregate that is being guided by IS 383, even coarse and fine aggregate. And for fine aggregate for concrete, the sand should be of zone 2, medium sand. So make it sure the water, mixing water should be potable water, clean water, free from all contaminations, all organic matter. Right? It is not that you can take water from anywhere and go for concrete mixing. So quality of water has to be good. Source का. But if source changes, so the contractor changes source, again you have to get it approved. But theoretically that is there, but it hardly happens. So source approval, lot approval for manufactured item. Suppose manufactured item is there, cement, steel, that's manufactured item. But naturally occurring materials like aggregates, sand, soil, they we get it from certain natural source. So source approval is must. Okay. Approved by the authority in charge, whoever may be, if it is consultant, supervision consultant, authority engineer, if he is not there, then if it is, if there is a supervision consultant, then it has to go through executive engineer. So he will approve it. And what is the criteria for that? Whether those are meeting the standards of quality or not, as per IS 383. Yes, yes. That's the process. Because if you do that, no, that will be easy for you. So when you control the quality of the raw materials, the first one is the raw material, then is the processing of raw material. So when you control the quality of the raw material, half your work is over. But if the quality of the raw material is not up to mark, you can't do anything. So this is very important point. There are only two parts, no? Quality of the raw material and processing. And then you get the finished product. Processing is the next part. So then comes site clearance shifting. You already know this, demarcation of the right of way, demarcation of area, removal of trees, amenities, everything. That is not every, I won't waste time in these things. Then setting out, transferring the alignment by reference pillars. Then I will switch over to the foundation, open pile and well foundation. Mm. Yes, yes. Mm. 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 No, see, the basic point is that there has to be at least two reference pillars in the entire linear project. If it is a linear project, a very lengthy project, And with reference to those standard benchmarks, you have to set up some reference pillars in between, because you cannot every time you cannot carry the level from the reference benchmark. So it is better to have near every pier or near every apartment one reference pillar transferred, RL and coordinate written there. So with that you can easily carry. So what we did in our Namkum bridge, when the pier got height gained height, so we marked the level in the pier shaft itself, and from there, with the help of taping, which is accurate, you can. So there will be error of 5 in leveling, because that's the least count of the staff. But when you do from the, suppose you mark the level in the pier shaft at the bottom, and with the help of that, when you start scaling the height with tape, that will be measured in exactly. So that can be done to prevent any error. But if there is a error in level, so the only area where you can adjust the error is the pedestal. Yes. So there is no where you can't no further scope. Yes. Hmm. 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 Arey, oh my God, that's too much. Hmm. 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 If the error is rectifiable, then it can be rectified. If it is beyond the hope of rectification, how can it be rectified? If it is up to 2 meters, it's beyond. Suppose it is if the pier cap is below 2 meters, so you can't even cast a pedestal of 2 meter height. You cannot lift the. Hmm. Pedestal height you can go. Yes. We can go up to 350, 400 mm. Yes. So that is the only scope left. Mhm. No, no, that's a very Himalayan blunder that has been committed. So how, because this is not, this is because of not irregular supervision. So supervision has to be there for every stage. Somebody has to check it. Okay, okay. So I will answer that in subsequent part. Right now will complete the main part. Okay. So open foundation. This is the uh, uh, bridge in the river. Uh, so first we come across two types of mainly just pay attention to it. Hello, Anshuman. So we encounter two types of open and pile. In our cases, even in WRD, even BCD, or maybe in DWSD. So mainly open foundation is there, and in case of bridges and it's pile foundation. So open foundation, we have to prepare excavation plan showing the ground level, proposed founding level, and site batter. So if we go deeper, there has to be site batter of 1 in 15, otherwise the site will collapse. So, and the bottom of the excavation has to be 500 more than the size of the footing on each side for providing shuttering, for cutting to drainage, everything. So there are 3 to 4 vital points about open foundation, which I will elaborate, because these are the human errors people commit. So open foundation should be constructed in dry condition. But if dry condition is not available, dewatering has to be resorted to. So what happens when we start dewatering and concreting? So when pumping is going on, when the water has come above the level of the leveling course, PCC. So along with the water, cement is also extracted and they get pumped out. So this is a very Himalayan blunder we commit. So we should not do that. So I will suggest what is to be done. So in open foundation, make a chew drain around the annular space of 500 mm and take it to a sump where water will collect, and from that deep sump, you start pumping. So water will not rise above the PCC. So water oozing out from sides, they will shallow drains all round, and they will go to the deep sump. From there, you start pumping. So never allow water to come above PCC, because if it comes above PCC and concreting is going on, so you will not be aware where has the cement gone. Ultimately, M35 will become M15. So never do that. But if in some case, if water comes up and concreting is burned, stop pumping. Simply use some tamping method if it is some of low height, but never vibrator. Vibrator will agitate the concrete, and again cement will come out. And that's why in underwater concreting, vibrator is not allowed. Only tamping method is allowed. So this is a common mistake we commit. So, but best thing is not to allow water to come above PCC level in the main concrete portion while concreting is being done. So it can be done by providing a drain and taking it to the sump and pumping the water from the sump itself. Okay, got it. Now, it's yes, the water level should be kept below founding level by pumping. It should never come up. No concreting should be done in flowing water. Suppose you are doing some foundation work in river, then basin has to be constructed with sheet pile. The velocity of water has to be brought to zero. You can do underwater concreting in standstill water, not in flowing water. Again, flowing water will draw concrete, cement from the concrete. So this is another precaution for laying foundation in such excavation. In case of excavation rock, annular space around the foundation. So now 500 space is left all around the foundation, because 500 at least working space and the drainage space. So that is to be filled with concrete, annular space. Okay. Many people do not fill it because there is advantage of that locks the foundation with the rock. So it is a 600 mm in rock and 1.5 meter in it's a moderately weak rock. So that will give you a lateral stability of the foundation also, and that will prevent erosion. When suppose erosion and eddies form in the river, so if it is not sealed, it will go to the bottom of the rock and start eroding it. So that will lead to the undermining of the uh, foundation. Okay, got it. So now, what is minimum embedment? Of 0.6 meter in case of moderately strong rock. Some people say hard rock, but there is no classification of hard rock in the classification of rock. So it is ideally moderately strong, moderately weak, excessively strong, very strong, like this. So moderately strong means if the FCK or if the crushing strength is of 12.5 MPa and above. So you can, it's very easy. When you understand this terminology, what will happen? You take a core from the bottom to the foundation and you testing in UTM or unconfined compressive strength. And if the crushing strength is more than 12.5 Newton per mm square, which is 12.5 MPa, that means it is moderately strong rock. Go ahead. So this is a very technical thing. And if it is below 12.5 MPa, between 2.5 to 12.5, it is soft rock, which is defined in the book as soft rock, but it is moderately weak rock. So criteria for embedment is 1.5 meter. There. Is it clear to all of you? So never go by visual inspection. Oh, this seems hard, so it's hard. Always go by technical specification. So anything above 12.5, it is just like 12.5 FCK, isn't it? So it is just like a strength of 12.5 grade concrete. And so it's so as simple as that. So in the case of casing type of foundation, if there will be water table above the founding level, then how is it going to be water? Water because we not be able to create some there. Okay. So even if there is a standing water, there is a specific procedure of doing concreting in standing water. Flowing water should not be there. So when you provide sheet piling or caissons all around it, even if there is leakage of water, That can be done by trimming method. Trimming method I will explain you in pile foundation. So there is a pipe through which concrete is taken down, and it is the up and down procedure of the trimming itself compacts the concrete. So there is no vibrator in that case. We don't have to apply needle vibrator, because if you apply needle vibrator, then cement will get agitated, concrete will get agitated and mixed with the water, and there will be cement loss. So have you seen any vibrator being used in pile foundation? No. That's the reason. Cement content may go high by 10%. Yes, of course. So there are two cases: one concreting in dry condition, one concreting in underwater. There are two different procedures. So coming back, next is pile foundation. So we ultimately cast in situ board piles. We are doing in our case cast in situ board piles. So cast in situ board piles, most of you are already aware. The borehole is made, then concrete is done, phasing is lowered, concreting is done, and the pile, that is called cast in situ board pile. Now, the most important part is that what type of boring equipment or borehole making equipment is to be used. There are two types mainly. One is called percussion type. So percussion, by the name itself, percussion means to hit hard. So like drum is a percussion instrument. So you go on hitting it. So hammering type, that's called percussion type. The second one is rotary type. So there is a hydraulic rotary drill. So normally earlier, 10 years earlier in Jharkhand, only percussion type was used, that is baler and chisel type. So there is one chisel which is dropped from height that breaks the rock, and there is baler which picks out the excavated material. So that is baler and chisel type. But nowadays, because this hydraulic equipment for boring, that is costly, so in mega projects it can be used, and it is being used. So it's better to go for the rotary type. Rotary type drilling equipment, that is hydraulic, that applies torque and cuts the rock, cuts the soil strata, and whatever debris is there, that's taken out. So I will elaborate how to do it. Methodology: first decide, depending on the subsoil. Suppose if the subsoil is of clay soil, then a rotary can drill pile foundation very fast. So, but if it is rock, then also rotary can do it. But if it is very hard rock like granite and basalt, so simple rotary can't do it. So there has to be some extra arrangement in the rotary, that is called core barrel arrangement, with diamond bits all around that cuts and takes the entire rock, solid rock that can be lifted, which you can see it yourself that it's rock. Okay. The pile boring shall be carried up to the indicated level. So what is the desired depth? It is already indicated in the drawing, but sometimes even the confirmatory boring is not representative boring. So confirmatory boring is done at what? Only one point, whereas the pile is spread all around. This gradient of the rock may be slanting. So this side the level will be higher, that side level. Ultimately, that has to be decided by either the level indicated if you are able to achieve it, or by IS 2911 rock socketing depth if that is achieved. So that is 1 to 2D for so-called hard rock, then moderately weathered rock. So 2 to 3D for weathered rock, and 3 to 4D for this one, weathered rock. So it is there already in IS 2911, but uh, this is logical because it depends upon diameter of the pile. It cannot be 0.6 meter. So higher the dia, higher has socketing. So how to ensure that I have reached that strata? So there are several methods. One, from the wash of the borehole, you can see some rocky strata coming, but that's also visual. So the ultimate thing is that's in IS uh, 78, bridge code for IRC 78 for bridge code and foundation. It's their pile penetration ratio. That sounds logical. So when rotary is going down and cutting, so if the penetration is very less and torque is very high, that particularly means that is a relatively hard stator. So pile penetration ratio formula is there. So when PPR is related to n value, you can relate it to n value. So when you first strike the rock, so you note the depth. From there, you start counting the socketing length. And when you go down, you start noting. So when the torque is very enormous, RPM is very high, but penetration is very less. Suppose only uh, 10 centimeter in 1 hour. That means it is relatively hard stroke. Hard stroke. So we can make a calibration chart according to the, from calibration, we can, for every instrument, there can be a calibration chart which will indicate what is the state of the rock depending upon the pile penetration ratio. If it is suppose going 3 meters in 1 hour, that means sand, isn't it? So yes, termination is written there in IRC 78. When you go there, how to terminate file. You can make your own calibration chart depending upon the strata also. But when core barrel is used, core barrel, so that's a very costly equipment which was used in this Siramtoli flyover also, monopile. So core barrel is a very costly type of arrangement which cuts the core along the periphery. So it will make a whole circumferential groove, and it will go down, and by shaking this, it will completely pick up the entire core of 1 meter. 1.2 dia and 1 meter height, it will come up. So you can, from that also, you can take a core by core cutter and paste it in UCS. And if it is 12.5 and above, so these are highly technical and scientific things, which is not to say not followed mostly. Okay. So, but for knowledge sake, when you start going into that, you will have many ideas where to stop the pile, where to terminate the pile. Yes. This is because of the fact that confirmatory boring is done at a location, central location, mainly, or some, if not at central location, somewhere near. Suppose bridge is to be constructed here. Confirmatory boring. Yes, boring. But suppose you make a boring here. Yeah. Profile of the rock is like this. So confirmatory boring comes at the peak point or the valley point. So that doesn't indicate the level of the rock everywhere. That's why it changes. When you make a pile there, it will go 1 meter down. When you make a pile here, it will go 1 meter up. So it's not that the entire strata is horizontal plane. Can it be? No, nature is not like that. Nature is never in regular shape. Understand it? Nature is always in irregular shape. Nature is never in a straight shape. Nature is always in curvilinear shape. Even Earth is not straight. Hello. Oh. Hmm. So that varies. Now, conformity boring is only of 4 inches dia, whereas your bore at the site itself is of 1.2 dia. So, which is more representative? Apply your common sense. Conformity boring is 4 meter dia. Suppose there is a big boulder, and that is longitudinal boulder of 1 feet. So, in conformity boring, it will come as a rock. Okay. But when you spread across, it's not as rock, it is isolated piece of boulder. So, many things are discovered during actual pile boring, and we have to take a decision based upon your experience, based upon your knowledge, and knowledge sharing also is there because many people take decision. What is there? Under, suppose If the nearby Hmm. Hmm. No, it's already defined in conformity. I think it's 5 to 10 meter below that. Ah. So that will not give us impression that it is a shallow rock. But there is another test called, I think, seismography test, which gives the extent of the rock. So that is a rock profiling test. So when you carry the seismography, vibrations go down, then come up. When you measure it, it gives the profile of the rock along the entire alignment. So it will come like this. Rock is going like this. Ah, ah. Yes, yes, of course, of course. For measure mega projects, seismography test should be done along the entire alignment and 5 meter or 10 meter this way or that way. So that will give the, like, thermal imaging, so just like rock imaging. So that's a test. But it's not being done here because they entirely depend upon conformity boring and their results. So just for this sake, I have told you. So this is how a pile case is made. So in pile case, there has to be one mastering also inside so that you get the shape of the pile and exact this one. And on that mastering, the longitudinal reinforcement are placed there, then transverse reinforcements are there. And then for cover, that's very important. So cover cannot be like cover blocks. It is in form of wheel, roller blocks. So it is inside the central hole goes in the transverse reinforcement. And when you put the case down the borehole, that wheel rolls. Okay. So there is no breakage of cover block. So it will roll down and bring the entire case into vertical profile. Okay. So that's very important because we have to maintain a cover of at least 75 mm in foundation. So that wheel itself is of 150 mm and the central hole is at middle. So the outer cover is 75 mm. So that is to be placed staggered so that you get a cover. Otherwise, if it is one-sided, there is no cover, then it will be subject to corrosion. So 75 mm uniform thickness of side cover has to be there in pile. See, this is cover block. Can you see it? Here, there is a cover block there. Reinforcement shall be provided. These are all, uh, yes. While enforcement case is done, it must be ensured that proper rolling cover blocks. These are called rolling cover blocks at 2 meter intervals. Okay. So these are the precautions of concreting underwater. So your question gets answered here. So there are two different methodologies. Concreting underwater is always done in still water with Tremi method. Okay, Tremi method. Tremi is nothing but a pipe of at least 200 mm dia, 200 mm, 8 inches dia. Now, what happens? The pile foundation should be completed continuously in one go. We cannot give a break. That's very important. I will tell you why. Because most of the mistakes that people commit, they take lunch in between, 1 or 2 days time is there. By the time the dirty concrete remains below and the pile integrity is lost. So I will tell you. Yes. Yes, I will tell you what happens in Tremi concrete. In Tremi concrete, there is a Tremi pipe. Okay. So suppose pile depth is 19 meter. So we have to calculate the length of the Tremi pipe. Tremi pipe should be 0.3 to 0.5 meter less so that concrete can spread. So 18.5 meter. Okay. Now there is a hopper above. In Tremi pipe, there is a hopper placed above in which concrete charge is placed. In hopper, there is a stopper plate. So it's not that the complete charge has to go suddenly. So there is a hopper plate attached to wire. When the hopper is full, you pull the cap, so the whole charge goes. And before the cap, there is one another, you know, polythene or gunny bag sort of thing, which pushes the water first. Before the hopper cap, one gunny sack or something like that has to be placed in the pipe. So when the concrete goes, the concrete doesn't get washed in with the contact with the water. So that gunny sack or that goes below the pipe, and that displaces the water, and that does not allow concrete to come in contact with water. Okay, so that will displace the entire water if the charge is very heavy. If the concrete is going very feeble, slowly, gradually, it can't displace. Concrete will get washed in the water, and water cement ratio will get altered. Okay, so eh? Yeah, workability. Pumpable concrete का तो ज़्यादा होगा, that is around 150 to 200 mm slump. Normal concrete का तो होता है 50 to 100, but pumpable concrete minimum 125, but if it has 100 to 200 mm slump. Pumpable concrete का डिजाइन ही अलग होता है नॉर्मल कंक्रीट से. That concrete has to be pumped. ठीक है, so that concrete which is going down the trimming should be of high slump. That will displace the entire water, and water will come up, even the bentonite solution. And now your point is here. There is a debris below, some mud, some loose soil which has accumulated. So that is pushed above. Concrete is going down the pipe, and that dirty debris, graffiti, or soil, or which has accumulated at the bottom, that is pushed by concrete charge, and that works above. And that ultimately comes at the top. And that is dirty concrete. Did you get my point? All of you should know why. That is called latent concrete, dirty concrete, or porous concrete, or concrete mixed with mud. Because the first charge, bottom of the pile will never be so clean, isn't it? Because ultimately everything settles. In water, everything settles down. So that will push. So concrete is going through the pipe, and it is working up in the angular space around the pipe. Okay. So did you get all? Is it clear to you? Now, when it comes up, okay, pipe should never be withdrawn from the concrete mass. People often commit mistake. They never calculate the height of the concrete, because volume of the concrete that has been poured, you know the area, so you can calculate the height, and you know the length of the pipe. So in any case, the pipe should be 1.5 meter in the concrete mass. Okay. So suppose suddenly you pull the pipe above the concrete, what will happen? Mud will come and make a suppression layer. Pile will be discontinuous. Okay. Now, even if you pour concrete there, it cannot be completely displaced. So it when 1.5 meter pipe is inside the concrete always, that 1.5 top will always keep working above, and below will set. The concrete which is below, now they will start sitting after half an hour, and concrete which is in motion, that will not so. So ultimately, that when the concrete, yes, to be sure, no, to be sure, you have to apply the thing which is here. Okay, how? You know the volume of the concrete that has been poured. You know the area of the pile. You know the depth, height of the concreting which has been done, and you already know the length of the pipe. So as concrete progresses, the top 1.5 frame becomes in 1.5 meter segments heading. So you can remove only 1.5 meter at a time. So how many you have removed? Initially it was 18.5. You have removed 3. So now it is 15.5. So from that calculation, you can calculate how much of my pipe is within the concrete. Okay. So everything is technical. But labor sometimes, though they do not calculate it, they simply by the feel of the pipe, they gauge it, and sometimes by error, human error, they get out. So that is a mistake. When that is taken out, pile integrity and continuity will be lost. Okay. So Concreting should be done continuously up to level sufficiently. So continuous, you have to plan in such a way. It cannot be done through normal, concrete mixers. They can't produce such a huge quantity of concrete. So it has always to be done with batching plant and transit mixer. And for the first charge to be heavy, keep three transit mixers, two at the site itself. You pour one charge and continuously another charge. So when you give a continuous heavy charge, the entire debris will come up. Otherwise, if you go give a small dose of concrete, no, that will never come up. So when you want something to come up, you have to push it. They give a heavy charge of concrete. No, no, no. So height of fall is only zero point 0.5 meter. No, that will I will come. Height of the concrete fall should never be more than 1.5 meter. Okay. So if by somehow it is coming more than 1.5 meter, and if segregation is there, here it is only 1.5 meter. No, only 0.5, because from bottom and top of tremie, 0.2 through 0.5 gap is there. But suppose height of the concrete fall is much, then there are many things. Concrete pump, last trajectory can be used, or elephant chute. There is one conical and one pipe. Suppose 2.5, 4 meter gutter is to be casted. So you pour the concrete in that conical chute, that is called elephant trunk, and it will deposit it here. There are many mechanisms. So cutoff level. So suppose pile cutoff level. That is the pile cutoff level is the level up to which we remove the dirty concrete. So at least we go for 1 meter or 1.2 meter removal of the dirty concrete. Okay. So it has to be cast up to level 1 point sufficiently above the cutoff level. Has the electricity come? These are normal things you will get in the code. Depth of pile cap projection. Now, this is very important. Second one. The pile head should project in the pile cap at least by 50 mm. Why? Because the reinforcement load come on the pile head, not on the leveling course. Many times people commit mistake. The level of the pile cutoff level and the leveling course is same. So the load first comes on the leveling course, and when leveling course settles, then it transfers. That's why slides 11 is there. So this many people do not care for this. So when you break the pile, so first we have to make excavation around the pile, then do PCC as per level. And while breaking the pile, we have to mark 50 mm above the PCC, and that is the level up to which pile can be broken. When you break the entire pile up to PCC level, what will happen? Load will get transferred to the PCC, not to the pile head. So pile is meant for taking the load directly from reinforcement. So it has to come on the head, not on the PCC. So this is a human error most of the people are committing. This is very important. So this now, why this? 25 mm, come here. Because minimum bottom cover and side cover required for foundation in all cases, in all structures, be it building, be it WRD, be it DWST, which is there in foundation, it has to be 75 mm. So 50 mm, this one, and the reinforcement which is placed on the pile cap, there is 25 mm curve block. So entire it comes 75. 50 plus 25 is 75. Okay. This is also very important. You note this point. You won't get in many publications also these things, because this is sometimes you learn by experience. No, why this is there? This, this is a standard leveling. This one offset. Suppose this is a pile. So pile has to overhang beyond the pile. Pile cap has to overhang. That is a standard 150 mm. Because when it is flush, no, there will be cracked along that. So suppose this is pile. Pile cap has to at least have a overhang of 150 mm. How always 150. I mean, design also, city also they will give you 150 mm. So this is how when pile is broken, you will get this reinforcement exposed, and this dirty concrete is removed. This one is there. Now here comes. We should always conduct a pile integrity test. Okay, pile integrity test is done. It will 50 mm will not be visible here. You can see here it's slightly above. Okay, but to be very perfect, no, because when chipping it is never always same. It becomes a regular shape. So if you leave the liner of 50 mm, so you will get a perfect shape. Okay. Now pile integrity test is done. PIT. Pile integrity is test is done before pile load test, because whether pile is continuous or not, whether integrity has been broken, whether there is a necking somewhere or collapse of soil, so that PIT will give you. So a hammer is struck on the top here, and its reflections again is recorded, and there is a mechanism. When you go in detail, you will know it. But you just, as of now, you understand pile integrity test is a must. So if you conduct pile integrity test on every pile, that's well and good. So in some of the cases, contractors themselves, they conduct it. No, 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 no. Pile, working pile. Pile PIT is conducted on working pile. PIT जब भी होगा working pile पे ही होगा. हाँ. If it fails, then you have to make extra pile. Contractor has to bear it. But there can be another pentagonal. It has been done sometimes. So 6 piles are there. That pile will be there itself. You make another pile there. So after, if the pile passes in PIT, then go for pile load test. Okay. So pile load test can be done. So it is there. Suppose up to 50 piles are there, two routine tests. If 50 to 100, I think it is 3 and 2% of the total number of piles. It's written in the book. But after leveling, after breaking this pile. Yes, yes. Suppose if this pile fails, pile integrity, beside that we have to make another pile. And we will take into consideration the consultant, what will be the strength of this pile, another pile, whether group of piles will sustain or not. Okay. Huh? Mostly what we prefer, sir, basically do the piling in symmetry so that total load can be distributed evenly. Yes, yes. If but if a pile is basically creating PID, so another pile, and that is load transfer is centric, sir. Load transfer is centric. Accordingly, the center of the pile may change. So that will be incorporated in the superstructure, because it has happened. I won't name the project. It happens, and it always it has happened. So pile can be done in any shape. Normal shape is regular shape. It can be like this pentagonal. It can be rectangular. Along the road, it can be lengthwise greater. With suppose there are two pipelines running, so pile has to be designed in such a way that it can be accommodated without shifting the pipe. So, yes, why not? According to this, ultimately, you can't work on a defective thing, no? When the defect has been detected, so we have to take into account. So many contractors are so this one concerned about it that they themselves conduct PIT in every pile, because ultimately their stake is there, na? Even if you don't say, he will conduct. All mega contractors. So they have to be very sure. Then pile load test, dynamic pile load test. Dynamic pile load test comes after that. So static pile load test, that is a very standard one, but it consumes a lot of space and a lot of arrangements. So people are now conducting dynamic pile load test. So some of the contractors are conducting at least one dynamic pile load routine test on every pile cap location. PIT in every pile, they are conducting themselves. Even if it is not there in the specification, because they can't take chance. Because foundation is the main thing, When the foundation is not strong, how can the superstructure be strong? So some of the mega contractors, they are doing it themselves. If it is not their provision, they are in the contract. So for dynamic pile load test, again, the head is to be built up. We have broken the dirty concrete, then head is to be again built up to top level. Then after setting for at least 15 days, then one standard hammer load is dropped and the waves generated analyzed. That analyzer is there, and that gives, you won't believe, that gives the shaft resistance of the pile, the end bearing resistance of the pile, and PIT also gives the length of the pile also. It will give you how much is the length of the pile. Apart from that, so dynamic pile load test will give the shaft resistance, end resistance, the pile capacity, everything. No, 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 not no, no, not before pile cap. Before pile cap. So you have to make head of a fresh concrete, okay? Because dirty concrete has been broken. So if you drop on dirty concrete, no, it will crush. So you have to make. So after you can conduct it after 15 days at least. Normal thing is 28 days, but all these things take a lot of time, because when you do concrete trial mix design, it takes a lot of time. So there are some ways, shortcut methods also. Hmm. Hmm. When you go by the procedure, dirty concrete will always come at the top. But when you have committed error, PIT will detect your error. No, no. During the process, you can when the pile has been not been withdrawn, and the pile casting is continuous, the dirty concrete has to come on the top, because there is a continuous pushing charge. So where it will go? It will come on the top. Error can only happen when you discontinue the pile casting or you pull the pipe from the mass concrete. Hmm? Hmm. No, there is a procedure given. In yellow book, there is a procedure already given. Suppose by chance you have withdrawn the pipe for some reason, so there is a recovery also. Immediately you put the pipe inside the concrete mass. Suppose the concrete is plastic concrete. Suppose the concrete is hardened. There is no chance, because the dirty concrete has already hardened there itself. So the dirty concrete can move as long as it is in plastic state. So when it is continuously in moving condition, so it won't set. So that dirty concrete will come. But suppose you immediately withdraw the pile, there is a procedure given, there is a long procedure. Again, you have to put a cap there at the bottom plug. You have to insert forcefully inside. And if it is in plastic state, if you start, that dirty concrete will come at the top. So there is a procedure given in detail in yellow book. So what happens when we commit mistake? Now, this is the enforcement for the pile cap. This is pile shaft. So I will not go substructure. So regarding, we all know what is substructure. There is no need of going in detail. Now, pier caps and abutment caps, pedestals. So pier cap, what mistake people commit is that sometimes they cast pier cap in horizontal. Casting should be in horizontal, but finishing should be slightly in gentle slope towards the river, so that whatever water comes from the pier cap, that is drained from so there will not be any vegetation growth. So above the pier cap, after casting the pedestal, you can make one artificial camber, okay, so that if the water is oozing from expansion joint, then the water can be drained And if water is not drained, then there will be a lot of vegetation growth on pedestal. Then the most important thing, pedestal. So pedestals are often, this is one of the most important thing which transfers the load from superstructure to the substructure. But being the most important thing, sometimes becomes the most neglected thing. And sometimes it gets crushed. There have been several cases of failure of bridges where pedestals themselves have crushed. So when pedestals crush, there will be level difference, the span will get dislodged. So, yes. So pedestals should be of higher grade concrete than the pier. If it is suppose M35, at least its pedestal should be M40. Horizontal seating should be there. It should not be like slope because bearing has to come on that. Then it has to be cured properly, and there should be proper vibratory effect impact should be given so that it becomes a dense mass and curing for at least 14 to 21 days. So sometimes engineers leave it to the munsis and laborers on site. Oh, you construct it, and so that is to be taken care of. I won't name the bridge, what has happened there. So, now coming to the superstructure regarding all across all departments, shuttering, formwork. This is very important. Sometimes formwork they fail because there is no proper support from below. There is no proper bracing. So engineers have to check the formwork also, at least whether the support is sound, whether bottom plate has been given, whether bottom pedestal support there is a tower shuttering, bottom pedestal has been cast. Then drainage of water, we have to divert the water away slightly. Never construct. Many people and contractors, they make a mistake. They make an embankment to the river bund and they erect on that because that will restrict the waterway and that will induce erosion in the central area. So, uh, finish the substructure work and even the bridge work before the start of the monsoon season. So you don't have to go in the riverbed and blocking a part of the river. Okay. So now suppose there is a pipe shuttering. So vertical pipes as well as bracings, they are very important. If you provide only vertical pipe, no, shuttering is bound to fail because while casting load comes eccentrically. We start from this way, go through that way. So formwork is very important. Robust formwork that needs to be at least checked by the engineer whether this is sound or not. Okay. Now verticality of the pier. Okay. So formwork. What are the things that would be? Formwork should be watertight. There should not be any leakage of cement slurry. Formwork should be applied with shuttering release oil from inside so that when you open it, it comes off easily. Sometimes formwork get stuck with the concrete and when you open it, a chunk of the concrete comes. So release shuttering oil should be applied. Every joint of the formwork should be waterproof, either by applying some foam or some putty or some mechanism. Watertight formwork. Otherwise, when slurry leaks out, there will be honeycombing and there will be loss of water from the concrete. Huh? Yes, yes, yes. Yes, yes, yes. So it should be done. Suppose internal vibrator is there. First, I will come to the verticality. So before starting concrete, you have to check everything. Verticality. So from top, make an offset of 150 mm cantilever rod, hang one plumb. It is better to hang the concrete cube itself. Okay. Measure the offset at the top, at the bottom. If both are same, then it's vertical. Okay, from all sides. But some tolerance is always there, 4 to 3 to 4 to 5 mm. But that you have to apply your brain. Okay. Suppose on top setting is there, the bottom setting has been released. So offset will not be same. So you have to take out the thickness of the setting. So always use plumb bob for verticality in every lift. Don't leave it to the person there. Okay. Are you all getting it? Am I clear? It is applicable in every formwork, be it building, be it WRD, be it DWSD. Every formwork has to be robust, watertight, proof, and vertically test has to be done. Even in column gets yes, that's it. Building. It's very important. If it is not vertical, then what will happen? So vertically. Then side cover. So suppose in some structure side cover is 50 mm. So 50 cover blocks has to be provided. Then concrete has to be placed and compacted to layer not more than 450 thickness at a time. Okay. So 450 is described for internal vibrator at one time, so that you compact with needle, insert it by 300 and compact it, and vertically just insert, take it out, no inclined needling. Only no horizontal. Vertical, take it out, at a distance of 300 to 400 So not over, no over vibration is also no. Yes, segregation again. Then for pouring concrete, approx just insert 2 to 5 seconds and then take it out. Then for placing concrete for avoiding segregation, again height of drop should not be more than 1.5 meter. If it is more than 1.5 meter, then concrete pump last section, which is a flexible pipe, that can be taken down. And nowadays boom placer has come. You might have seen placer boom. So in hydraulic crane, concrete pump, flexible concrete pump is there. You can deposit concrete anywhere you want. You don't have to change the pipe here, 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 here. So that's called placer boom or boom placer. Okay. So new technologies have come. Yes, yes. High-rise buildings, even in bridges. Nowadays, you can't depend upon the head load laborers. Okay. Huh? हाँ। क्या हाँ सीरियस है काफी serious है that will attract water na there will be ingress of water that will lead to the corrosion then corrosion will lead to the spalling the concrete cover will come out it will get exposed. There are many mechanisms like this epoxy concreting. It can be leveled, it can be sealed, then there can be protective paint also, like anti-carbonation paint. Many technologies have come. So honeycomb should be avoided. When you do all these things, there will not be any honeycomb. आ गया तो उसको रेक्टिफाई करना पड़ेगा, बता दिए नहीं अगर ज्यादा डेप्थ नहीं है तो बहुत सारे ग्राउटिंग है, एपॉक्सी ग्राउटिंग है, सीमेंट ग्राउटिंग है, देन एंटी कार्बोनेशन पेंट है, प्रोटेक्टिव कवर पेंट है बहुत. अब है कि how to get a very smooth surface, how to prevent honeycombing. So if there is no water leakage, slurry, there will not be honeycombing. For you might have seen many of the projects, the outer surface of the concrete is as smooth as Sanmaika. How it happens? Because they will release shuttering oil first, internal vibrator and external vibrator also. Shuttering vibrator. That shuttering vibrator that shakes the shuttering to some vibrates the shuttering, and that breaks all the bubbles, and all the concrete is filled everywhere inside. There is no space left. The surface will become very smooth. So when we use external vibrators, shutter vibrators, internal vibrators for internal, this one. No, it has to be used. All mega contractors, they have to use it. They know how to do it. Even if you don't insist, they will use it. So even in Namkum flyover, it was used for the first time in my knowledge, shuttering vibrator, that shutter vibrator. So you will get a very smooth finish, and that smooth finish imparts longevity to the concrete. Why? There is no micro pores. Okay, the clear cover is perfect. There will not be any corrosion to the Reinforcement, because when corrosion gets exposed honeycombing, ingress of water and air, that will lead to the corrosion. So when you are apply your mind and you are very particular about these things, there will be perfect concreting. A very good question by Kundanji. Nowadays, electrical vibrators have also come, because that is very convenient. In our days, we had to mount that oil engine at the top, and sometimes that used to lead to an accident also. Now, only wire has to go up to the top. So, compacting concrete is very important. Finishing of concrete is very important. Okay. So, is it relevant to you also? हाँ 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 वो आएंगे, वो मेंटेनेंस में आएगा ही. Your question will come under maintenance part. Okay. So this is when all the pedestals were cast, clear caps, so you can see them. हाँ सारा नाम कुम का ही है. सुपर स्ट्रक्चर ये सब तो आप जानते ही हैं. जो आप जानते हैं उसके बारे में बहुत ज्यादा बताने की जरूरत नहीं है. ठीक है, ये तो प्रिकास्ट गर्डर सब है. ये लॉन्चिंग ऑफ द फर्स्ट गर्डर ऑफ फ्लाईओवर ऑफ नामकुम, उसका पिक्चर है. फर्स्ट गर्डर का लॉन्चिंग जो हुआ था डबल क्रेन से. सो कैसे क्रेन से लॉन्चिंग हो रहा है. सो थोड़ा विजुअल पिक्चर्स होने से एक आइडिया लगता है. सो इसमें क्या होता है, प्रीकास्ट गर्डर इज बेटर in my view, because when you cast anything on the ground, you can have better quality control, better compaction, better curing. So what we did in Namkum, we kept all the girders near the bank of the river itself, and there were 2 to 3 pumps which used to continuously take water from the river, which was very nice, good. There was a this one, a pond sort of thing away from the river, from where we used to take water, sort of well, clean water, and used to completely sprinkle. Asian cloth was there. So there was no shortage of water when you are constructing. So why not? Why can't we use water? So if it is available, we have to use it. हैं? क्या? नहीं नहीं, नॉर्मल आरसीसी प्रीकास्ट. हाँ क्या क्या? हाँ वो सब आएगा, उस मेंटेनेंस में आएगा. मेंटेनेंस वाला टॉपिक लेंगे ना. हाँ उस बियरिंग का मेंटेनेंस का. बियरिंग कोड की बियरिंग बोल रहे हैं. हाँ बियरिंग नहीं, हाँ तो वो आएगा जो मेंटेनेंस वाले में ना, मेंटेनेंस वाले में आ जाएगा. दो 2 cranes were used. Yes, गर्डर एरेक्शन में क्रेन एक्सीडेंट्स बहुत होते हैं because of not taking enough precaution. So engineering में दो ही चीजें हैं. Either you know it, and if you don't know it, then gather experience from someone else who is using it. And when both are not there, then quit your position. दोनों के बीच की जगह नहीं है. या तो आप जानते हैं और नहीं जानते हैं तो जान लीजिए, कहीं जाके एक्सपीरियंस जहाँ चल रहा है. तो when this flyover was being constructed, I was not aware of launching technology, to be very frank. So one of my relatives in higher position, he was working there in Ganga Digha bridge, where crane was being used. So I told him, kindly provide me 2 days experience there with your gang workers there. He agreed, and I went there, remained there for 2 days, gained experience, and came back. Then I started launching. So this is the only thing there, and there is nothing between two. Either you know it or you gain it, and if you can't do it, then quit. Okay. So in launching, normally in casting situ girder, they cast the web and flange first, and they cast the top flange along with the slab itself. When you launch a girder, the moment you launch it, compression is generated. Okay, in the top because of erection stresses. So when you leave the web itself, it will get crushed because web is not designed for the compression. So there has to be top flange like this. Top flange has to be constructed like this. Top flange, and these are shear reinforcement which will go into the slab. So top flange, there is a compression reinforcement in the top flange. So when you launch, it will take the compression generated due to erection, and it will not. So if you do without top flange, the web which is not designed for compression, will get crushed. Okay. So then sling, where we have to sling is, there is a belt that is called sling, which is wrapped around the end. So there also some extra reinforcement is provided at the sling position. So that is taken care during casting it. So we have to take a decision before whether we have to go for precast or cast in situ. Accordingly, design will change slightly, and arrangement will also change. So this is the beauty of precast girder. There is no need of erecting shuttering, and you can take out bracket from the top and go for slab. So that exercise is saved, and even when you do it while the road is open, this area is clear. Okay. Otherwise, you have to provide shuttering and close it. So at great height, it is not possible. So see, this bracket comes that side also, and then slab is cast. Then this is how it looks. This is curing completed at the top. Now, regarding this, I will tell you one thing. Prepare a curing register at the site, curing register, which component has been cast on which date, and paint the date on the component itself after setting. So what happens? Person who is in charge of the curing at the site, he continues curing the thing which has already been cured, and he will leave the thing which is to be cured, which is under 14 to 21 days. So that mistake is human error. Again, human error. वो क्या करेंगे? वहाँ के सुपरवाइजर हैं, पानी पिताते रहेंगे 32 दिन तक, 40 दिन तक, और जो अभी कास्ट हुआ है उसको छोड़ देते हैं. तो बाय क्यूरिंग रजिस्टर यू कैन मेंटेन ए चार्ट कि कौन सा कंपोनेंट क्यूरिंग के पीरियड से होराइजन से बाहर हो गया. तो आप एक बार लुक करके उनको थोड़ा सा डांट सकते हैं कि भाई आप ऐसा क्यों कर रहे हैं. कि आप जिसमें क्यूरिंग होना चाहिए तो उसको तो आप कर नहीं रहे हैं, और जिसका कंप्लीट हो गया तो वो क्या आलस में ऐसा करते हैं, तो उनको दूर नहीं बस यहीं पटा रहे हैं दिखाने के लिए पानी पानी. दिस इज ए बहुत बड़ा ह्यूमन एरर है. तो उससे करने के लिए एक कहीं नहीं आपको बताएगा कोई भी. हाँ, तो आप एक क्यूरिंग रजिस्टर रखिए, एक क्यूरिंग रिकॉर्ड रजिस्टर, और उससे उस पर सुपरवाइजर साइन कराइए, और आप भी चेक कीजिए कि हाँ कौन सा कंपोनेंट का क्यूरिंग होना है, हुआ कि नहीं. क्यूरिंग इज वेरी इंपॉर्टेंट थिंग. सबको पता ही है व्हाई क्यूरिंग इज नीडेड. You all know there is no need of telling it. So there is no need of wasting time. बेरिंग में तो अधिकतर हम लोग यूज कर रहे हैं इलास्टोमेरिक बेरिंग एंड पॉट कम पीटीएफई बेरिंग. तो इलास्टोमेरिक बेरिंग नॉर्मल ब्रिजेस में यूज करते हैं, लेकिन वेरी लॉन्ग स्पैन में पॉट एंड पीटीएफई करते हैं. तो इलास्टोमेरिक है 30 मीटर से अब पॉट एंड पीटीएफ में जाना चाहिए. हाँ, कांटेक्ट में तो है ही. पॉट एंड पीटीएफ बन रहा है, उसका स्पैन अब पता नहीं है, आई डोंट नो. हाँ, तो नहीं, उस पर भी निर्भर करता है ना. सपोज इट इज कम्प्लीटली हॉरिजॉन्टल ब्रिज है. हॉरिजॉन्टल ब्रिज में तो प्रॉपर सिटिंग होगा, वहां पे दिमाग लगाइए. जहाँ पे इंक्लाइंड है, बेरिंग हैज टू बी हॉरिजॉन्टल, हाउ सिटिंग कैन बी देयर. पेडेस्टल में भी नहीं ना, नहीं, इंक्लाइंड हो जाएगा ना. उसको बताएंगे बाद में, टाइम मिलेगा तो मैं बताता हूँ. नहीं, सुपर एलिवेशन. सुपर एलिवेशन के दो है, या तो गटर को ही हाइट वेरी करते हैं, लेकिन बेस्ट थिंग इज पेडेस्टल. पेडेस्टल आउटर साइड हायर रखिए, इनर साइड लोअर रखिए. नहीं, लैटरल रिस्ट्रेनर रहेगा ना. लैटरल सिस्मिक रिस्ट्रेनर भी है, लैटरल आर्च का तो देना ही है, डिस्लॉज नहीं होगा. इलास्टोमेरिक बेयरिंग में क्या है कि बेयरिंग शुड बी प्लेस्ड हॉरिजॉन्टली. इलास्टोमेरिक एकदम परफेक्ट. पेडेस्टल को भी वैसे ही करना है. पेडेस्टल का टॉप सरफेस नॉट हॉरिजॉन्टल है, स्प्रिट लेवल से चेक कीजिए, चेक विद स्प्रिट लेवल. देन इफ इट इज नॉट, देन रब विद कार्बोरेंडम स्टोन. देयर शुड बी अ ग्रुप ऑफ एटलीस्ट 6 mm. हाँ, सिटिंग के लिए. देन अप्लाई द टू सॉल्यूशन inside below the bearing and on the top of the pedestal. Then stick it, then hammer it so that it gets in the position. Okay, so horizontal horizontality has to be maintained at any case. कौन सा? हाँ, bearing must be placed between two horizontal surfaces and true plan position control line. Sitting concrete surface shall be free from impurities, everything. But main thing is that while casting, it cannot be truly horizontal. Okay. At the time of before placing bearing, you have to check with the spirit level, and if there is some irregularity or then there is one carborundum stone. When you start rubbing it, the concrete surface can be abraded and it can be made horizontal. Okay, so that's a very important precaution. Otherwise, when you leave it to the person, he will simply put the bearing, even he won't make a groove. So to make a groove of 6 mm, just after casting, make a ply board of 6 plus 5 mm plus size of the concrete and press it in the concrete, so you will get a groove. So that bearing has to go into that 6 mm groove inside box. Okay. Sometimes people simply place it, so that will get dislodged. Okay. Again, I won't tell you. Expansion joints. That's not a very important thing to elaborate, but expansion joint, for a perfect expansion joint, while casting the deck, 300 mm space has to be left on both sides of the deck for fixing the expansion joint. Many people fix the expansion joint in wearing coat, which is very dangerous thing. It will come out soon. It's not. Yes. The anchorage of the expansion joint has to go. Suppose, where is the pen? Suppose this is the deck. Okay. End of the deck. So suppose 360 mm. So half, and it will be reinforcement will be exposed like this. Okay. Now this half is cast and this half is cast left on. When this is around 250 to 300 mm, this is left 300. Now both sides. Now expansion joint reinforcement will go into the body of the deck slab. The anchorage will go. Okay. So it is very important. So you have to leave a recess of 300 mm while casting. Bottom deck, suppose it is 360 mm. So 200 mm solid, 160 mm with steel. So it will L type recess will be there. So both expansion joints are fixed at the same time, so that its horizontality can be checked with straight meter edge. Suppose, how to erase it? Here. यहाँ यहाँ पे. हाँ. Suppose, हाँ, suppose it's truly horizontal. Suppose it's a river bridge. So expansion joint of both decks are truly horizontal. But suppose the flyover is in gradient. Okay. So this slab. So while fixing the expansion joint, we have to put a straight meter edge like this. So it has to be in line with the inclination of the. If it is horizontal and if it is inclined, there will be great sound. and it is always dangerous. No. So these are the things. You have to put a straight meter edge, and you have to check whether it is in line with the inclination of the deck or not. Okay. Now, now the most common type of expansion joint we use is a strip seal joint. So what is strip seal? So there is one. So it is like this. There is one flange. So it is made of iron. So there is one groove. Okay. Now the anchorage of from this will come in the body of the slab. Yes, like this, and like this also. And there will be one strip seal, rubber steel. It will be like loop. Okay. So when it expands, loop will expand. Now, what is the advantage of this strip seal? Water cannot go through, debris cannot go through, so nothing will gather on the pier cap. Okay. So strip seal has to be inserted before. Now, horizontality of this can be checked with a straight meterage. It should not be up and down. So both at the same level. So it comes in a combined assembly. So with welded assembly both. So we place, and after placing, you remove the welding. Okay. When you use separately, then there will be always error 2, 3, 4 up and down. Okay. Did you all get it? No. At once, but for wearing coat, suppose it is 75 the top should be 75 above the backside, so that when wearing coat is done, it becomes flush. Okay. So it depends on the thickness of the wearing coat. So while fixing the expansion joint, you have to take wearing. Suppose it is bituminous wearing coat, it will be 65. If it is concrete, it will be 75. But never go for concrete wearing coat. Go for always bituminous, because concrete wearing coat, when gets damaged, it's very difficult to repair. You have to close the bridge. You can't do it half and half. Vibration will be there. So bituminous advantage is that you can lay it while flying the vehicle on one side. So 40 BC and 25 mastic. 40 plus 25 is 65. So always lay BC above the deck slab, mastic, which is the wearing course, with anti-grit, anti-slip, anti-sliding, anti-skid grits at the top, mastic. So it will be slightly, yes. So, yes. So concrete is very difficult to compact nowadays. 75. Uh, no, no, no. Hmm. Ultimately, yeah, in that case, suppose you have to uh, overlay, provide overlay, then remove the existing layer, so that the top layer is always in flush with the top of the expansion joint. Uh, no, no, people are not understanding thing now. They are increasing the dead load also. They are increasing the gap also. Okay, because expansion joint, no, that will get impact load on the bridge, and that will damage the bearing. Okay, very good question. By now, for work staging, I think. हाँ? कहाँ? यहाँ. फॉर्मवर्क जॉइंट shall be look proof तो सब हो गया. फॉर्मवर्क, प्रेसिंग reinforcement, ठीक है. Reinforcement is a vital part like concrete. So, how to check it? So make a checklist. What are the things? Suppose I go to the site and without any preparation, without any homework, you will simply see visual inspection and come back. So before visiting a site, make things which are very important. Okay, so there is always a checklist. So this project was completed by checklist method. So there one page 40 points. Is the verticality okay? Contractor's engineer will say okay. Then my engineer will check. He will say not okay. Permission not granted. So okay. So there are columns like this. Is the bar size proper? Okay. So contractor engineer will say proper. My JE has checked and he said no, it's not proper. Then rejected. If lap length is okay, placing of lap is okay. So likewise that side cover okay, everything. So just like that, 50 points. So contractors engineer, they are very then particular. Okay, I'm not getting acceptance approval, so I have to make it okay. Even the barbenders and setting mistri, they also know that it will be rejected. So from the very beginning, they are very careful. So when you give leverage to them from very beginning, they will become very slack and very lazy fellow, and they will commit mistakes. So make you can according to WRD project also you can make a checklist. Okay, building also you can make a checklist or you know what are the requirements. नहीं क्या है कि before casting contractor has to get approval from the engineer. So how will he put? There are two methods. One is request for RFI method. मेल से आता है RFI को अटेंड करना है ओके की जगह तभी होगा. एक मेथड है जो नॉर्मल प्रोजेक्ट में है चेकलिस्ट मेथड जो हमने उस समय किया था. चेकलिस्ट मेथड में क्या है कि एक फॉर्मेट बना हुआ है. कॉन्ट्रैक्टर अपना काम करेगा और वो आपको पुटअप करेगा सर फ्रॉम माय साइड इट इज रेडी फॉर कंक्रीटिंग. So we want approval from your side. So first, our JE, I trained my JE how to check it. So he checked all these things and he gave 5 remarks in column of JE. Verticality, not okay. So if one thing is not okay, it automatically gets rejected. So the entire labor gang and mystery gang and shuttering gang, they know that if I commit mistake, it is a wastage of time. I have to do it again. So they are very particular. Okay. Now it comes to me as an engineer in charge. After JE has checked, I will apply certain checks. I will apply verticality check, side shuttering check, placement of lap splices and all that. If JE has also done okay, I will say not okay. So ultimately goes back to the contractor for rectification. So then after rectification comes rectified checklist. In rectified checklist is everything okay, approval granted for casting. If it is not okay, again re-rectified checklist. So they know that if I commit mistakes, I won't get approval. Okay. So this thing, I'm telling from my own experience, you are young scholar engineers, you can make your own checklist there according to the requirement of the project. Okay. And make salient, you can't check everything, but you check the foundation, you check the side cover, you check the verticality, you check the lap length, you check the bar size. And what are the other things that you can check? So make it a work culture, part of the work culture. Am I clear? Yes. Placing reinforcement. So in girders, sometimes reinforcement is very congested as per the standard drawing. You might have seen. And there are cases I won't name specifically because it will not be proper to name here. Some of the bridges have failed because of the congested reinforcement. Because the concrete could not reach the bottom of the soffit of the girder. The concrete the aggregates got entangled in the mess of the congested reinforcement and only slurry went down. Okay. So this is a human error. So always check the reinforcement. So I had devised a method. I always used to, during night, I used to take a torch and walk along the reinforcement of the top and see whether there is a congestion or not. Okay. So suppose there is many reinforcement have come together. So I used to tell the barbender push one vertical bar so that we get a space. Otherwise, concrete won't reach there, especially at the point of lap splices. So we have to lap splices has to be provided because our reinforcement comes in the length of only 12 meter, and if the span of the bridge is 24 meter, 30 meter, there will be so many lap splices. So no. It must at least bending wire should be at least 1 mm dia and a strong one. And but You have to pay special attention to those zones, life splice zones. So heavy congestion is there. So it's just like there is a big rasgulla, but it's not able to enter your mouth. So of what use it is? कोई मतलब ही नहीं है इसका. The concrete is there, but it is not able to reach point where it has to go. Is it of any use? No. So in the standard drawings, clear cover, covers, clear cover between the reinforcement is around, I think, 48 mm, 50 mm. But in any case, the horizontal uh, distance between two reinforced longitudinal reinforcement should be 10 mm more than the size of the aggregate, so that aggregates can go. So I had adopted one strategy in dry condition. After settling, I used to pour dry aggregates, that aggregates I am going to use in concrete, and I used to ensure whether my aggregates are reaching the bottom of the gutter or not. So when it's reaching in dry state, it will naturally reach in the. So it is a pure application of a human brain. It's not written anywhere. So there were cases when contractor insisted that give me approval in the day itself. In day it was very difficult to use a torch. So I thought what to be used. I applied one mirror. I reflected the sunlight into the bottom of the gutter, and I saw what is there. So, so it is a constant application of human brain. It's not that whatever is written is a gospel truth. So engineering evolves like this. Somebody has evolved it, no? So why can't you evolve it? Everybody can evolve it. Okay. And I think the name of the training session is Evolve. Oh, very nice. So it is a constant evolution. So by purely applying the thing which is 5 to 6 feet above the ground, which is you can evolve so many things. Okay. So concrete has to reach there. Okay. Now there are sometimes even the vibrators don't work. The needle vibrator has to go below in between the spaces. So the horizontal distance is only 40 mm, 50 mm, and the dia of the vibrator is 60 mm. So in bottom portion, you can use 40 mm dia vibrator, so that vibrator can go in between the reinforcement and compact the clear cover also, so that spalling will not happen. Hello, listen. So how to prevent a spalling? Prevention is better than cure. So the needle vibrator has to go to the bottom of the gutter. So even the clear cover will get vibrated, that will become strong, and 50 mm clear cover is there. So there will not be any reinforcement and spalling will not happen. But in case spalling happens, then I will give the remedy. Okay. So how to build a robust concrete structure? Concrete has to reach there. Concrete should be well compacted. Certain vibrator can be used. Okay. Now curing. Water curing is there, but curing compound. So there are impervious compounds like wax. When you apply, it makes an impervious layer, and that prevents water from evaporating from the body of the concrete. But curing compounds should never be used on that surface where further concreting is to be done, like top surface. Top of the gutter slab has to come. So if you apply curing compound, what will happen? The joint will form, it will become discontinuous. So great care has to be applied there. So that top surface has to be cured with water itself. Okay. Don't apply curing compound on all sides. But curing compound is applied generally in those areas where there is a scarcity of water or arid zone. Okay. But in any case, water has to be used. It's not working. See, special attention is to be given areas having space. Then materials for concrete, you all know that. So you all know the material. They are coarse aggregate, fine aggregate, cement, water. Then there are admixtures also. Admixtures are two types: chemical admixture and mineral admixture. So you are aware of the chemical admixture. Many of you may not be aware of the mineral admixture. Chemical admixture is plasticizer. Plasticizer is a chemical, means water reducer. So yes, water reducer. How? If the water cement ratio is low, the strength will be high. But if we reduce the water cement ratio, then workability will be affected. It will become very stiff. It will become difficult. So plasticizer is added. So plasticizer maintains the workability flow of the concrete so that concrete can reach in every nook and corner of the formwork when you vibrate it, and strength can also be gained. Okay. So mineral admixture, fly ash is a mineral admixture. So in high performance grade concrete, nowadays people use mineral admixture because they are finely divided powder and they fill every pore of the concrete. Concrete becomes impervious. There is no permeability in concrete. Okay. So mineral admixture, it is already there in high performance grade concrete. Hello book, it's already written in detail. So I won't go in detail about that. So these things are there. Now specified fresh concrete, how to produce it. Then mixing time should not be less than 2 minutes. Yes, yes. In design, no, no. This type of admixture will be decided in design mix of the concrete itself. Okay, design mix. Everything will be there. I will come to that point also. वाटर सीमेंट रेशियो का आपको पता है एडवांटेज. हाँ, नो नीड. Transportation of placement of fresh concrete, it should be deposited as soon as possible within half an hour of production. But suppose distance is very high, then retarder is added. So the setting time can be, suppose it has to come from Tati Silver to here. It will take 1.5 hours, 2 hours, transit mixer. So that is assessed and retarder is added. Moreover, transit mixer keeps on agitating the concrete, prevents the setting. So transit mixer is the best way to transport the concrete from there. Now, one thing I would like to, one of the human errors which have been committed in many projects, and after that we have learned, human error is more important to learn because many things you will get in book. Suppose there is a mega project and there are 3 to 4 types of concrete being cast every day, M30, M40, M50. Okay. Now, what mistake was committed earlier? Again, I won't name the project. So that is a mega project in Delhi. So yes, so the person, first the driver with M50, he went out from the and went to the destination project site. On the way, he took a small cup of tea nearby dhaba. By that time, another M30 was produced and he went there. He reached there earlier and M30 got pumped up in place of M50. So this error can happen in those mega projects. So there is a triplicate chalan method. So there is a triplicate chalan is issued, bearing the transit mixer registration number, bearing the grade of concrete, bearing the place where it is to be poured, okay, location, chainage, everything, and bearing the sometimes name of the site engineer, but that's not report. These 3 things. So one is kept in the office, duplicate in 2 copies, they are sent by the driver, and driver will take it to the site where it is to be pumped, and the site in charge will verify with the registration number of the vehicle, and he will sign and return one back again with the driver, and it will be kept in the record. Then it is foolproof mechanism. So people learn by mistakes. So when mistake got committed, then people started thinking, what happened wrong? So instead of, so all mixed design went haywire. So M30 got pumped in place of M50. So what will happen? Where is your mixed design? So this human error has to be eliminated. This I told you because I was dealing with this transportation of the concrete, and it shall be a temperature of not less than 5 degree and more than 40. If it is more than 50, then some steel ice. This one silos are used in the aggregate to maintain the temperature, but it rarely happens. It is there. Fresh concrete shall be deposited in horizontal layers, 450 mm thickness. See, form vibrators and screed vibrators. Screed vibrators is क्या हो गया? So screed vibrators is nothing but a plate vibrators. Suppose you have to compact slab. So use internal vibrator as well as plate vibrator, screed vibrator. So there is a tray type sort of thing in which there is a vibratory machine. When you pull it, it will go on vibrating and that will compact. It's better for slab finishing. Yes. protecting and curing concrete, especially now one thing I will share with you, because many people do not know it still. When the curing should start? How? After how many hours of casting the concrete? Eh? Okay. Actually, this I had raised in question with one of the bridge expert, Mr. Rana, but I was of the view that concrete should be cured as early as possible, after even high grade concrete within 4 hours. So once the concrete initial setting has happened and it has gained some hardness, if you start curing, you gain the strength of the concrete. Then another question was raised by some people. So will it not alter the water cement ratio? Then I told, if you do concrete underwater, what happens? Does the water cement ratio get altered? No. So how can the water cement ratio be altered? So start curing as early as possible. Many people think tomorrow the mason will come, he will make a bund. By that time, there are some surface losses, some hair cracks. So initial curing should be done by sprinkling water with your that's a pesticide sort of sprinkling thing. And even while the next day, what happens? Again, I won't name the project. That was a railway project along with my project. So railway was not aware of it. So he came next day, 10 o'clock, and there was a heat, scorching sun. There was surface hair cracks all the way because any surface moisture was there, lost. So start curing as early as possible. Nobody will tell you in any book, but this is practical thing. Even in the cube also. So as early as possible, initial curing should be not with flooding, with initial spray of water or wet Hessian cloth. You just wet the Hessian cloth and put it on top. Okay. And then curing compound तो टॉप में नहीं हो सकता, बाकी जगह लगे, साइड में लग सकते हैं जहां फर्दर कॉन्क्रीटिंग नहीं करना है. स्लैब पे आपको क्या है कि यू हैव टू डू वियरिंग कोट आल्सो, सो यू कांट अप्लाई क्यूरिंग कंपाउंड. ओके. Curing compound after you release the shuttering, साइड शटरिंग रिलीज करेंगे, लगा देना है. तो जैसे आप साइड शटरिंग रिलीज करते हैं ना, देयर इज सडन लॉस ऑफ water. So why water? There is a reaction water in the concrete, so that has to continue there. If the reaction water is lost and evaporated, the concrete will not hydrate. It will not complete its reaction, and it will not gain strength. So that is the main fund of curing. Got it? वाटर क्यूरिंग, क्यूरिंग कंपाउंड आ गया. आपको क्लियर हो रहा है ना सारा? हाँ. तो बिल्डिंग में भी आप क्यूरिंग अर्ली स्टार्ट करेंगे, अर्ली. ऐसा नहीं कि कल आज सो जाते हैं, कल उठेंगे, कल सोचेंगे. हैं? तो ये तो टेस्टिंग सैंपल है, कब कितना लेना है. 1 से 5 क्यूबिक मीटर में है तो एक सैंपल इतना इतना सब मिल जाएगा आपको कोड में. ये हमको बताने की जरूरत नहीं है, हमें की जरूरत नहीं है. हाँ, ये बहुत जरूरी है. एक्सेप्टेंस क्राइटेरिया क्या है? बहुत लोग सोचते हैं कि एफसी के अचीव हो गया तो मेरा कंक्रीट इज ओके. अभी कितना कर दिया, ये तो पहले वाला कोड से था. जैसे मीन स्ट्रेंथ ऑफ 4 सैंपल्स एफसी के +3 MPa, ये था. अभी चेंज हुआ क्या? और कहता है कि एनी सैंपल शुड नॉट बी लेस देन एफसी के -3 MPa. तो ये फेल हो गया. फेल हो जाने के बाद क्या, डायरेक्टली रिजेक्ट नहीं होगा. तब उसके बाद हम जाएंगे फोर कटर पे. फोर कटर से एस्टेब्लिश होगा, क्योंकि क्यूब भी बहुत एग्जैक्ट रिप्रेजेंटेशन नहीं है. क्योंकि पूरे क्यूब जो है दैट इज कलेक्टेड समवेयर एल्स, क्यूर्ड इन वेरी आइडियल कंडीशन. जब हमारा जो ओरिजिनल कंपोनेंट है वो आइडियल कंडीशन में क्यूर नहीं होता है. ओके. सो अल्टीमेट इज कोर कटर. कोर कटर के बाद होगा तब देखा जाएगा कि वेदर इट इज डिसमेंटल और थोड़ा सा टॉलरेंस के अंदर है. हाँ, अब इसमें आते हैं मिक्स डिजाइन में. थोड़ा सा मिक्स डिजाइन तो आप सभी पढ़िएगा डिटेल में. तो मिक्स डिजाइन, दैट इज द concrete is always designed for higher strength. So target mean strength, that is called TMS. So FCK plus 1.64 into स्टैंडर्ड डिविएशन, वही है टारगेट मीन स्ट्रेंथ 1 पॉइंट. लेकिन स्टैंडर्ड डिविएशन यदि नहीं है, इनिशियल मिक्स में हमको क्या करना है, वी हैव टू अज्यूम सर्टेन वैल्यूज. सो टारगेट मीन स्ट्रेंथ इज इक्वल टू FCK प्लस करंट मार्जिन. ट्रायल मिक्स के लिए करंट मार्जिन क्या है, M30 के लिए 12. सो M30 का डिजाइन कर रहे हैं, मीन्स M42 के लिए आपको टारगेट में स्ट्रेंथ होगा. लेकिन M50 से ऊपर जाएंगे तो दैट बिकम्स 13. वो कोड में है, वो एग्जैक्ट याद नहीं है, येलो बुक में है. सो तब आपका इनिशियल मिक्स तैयार होगा. ओके, जब आप थियोरेटिकली जाएंगे, देन आफ्टर प्रिपेयरिंग इनिशियल मिक्स, मेक 40 क्यूब्स for trial mix, this trial strength test, and note the strength gained by every cube, and by the formula of standard deviation you can find out what will be the standard deviation of my cube, my aggregate, my sand, my cement, and then redesign it. That is the actually a very lengthy thing. Okay, so first आप assume कर लीजिए इस पर FCK plus 12. हाँ, 7 days को भी आप एक्स्ट्रापोलेट कर सकते हैं अगर टाइम नहीं है तो, क्योंकि इस पर सारा प्रोसीजर. तब आपका क्यूब का डिजाइन का अप्रूवल है. तो उसके बाद आप एक्चुअल डिजाइन मिक्स करेंगे विथ टारगेट मीन स्ट्रेंथ ऑफ FCK प्लस 1.64 इंटू स्टैंडर्ड डिविएशन जो आपको आएगा. और उससे हो सकता है कि वो आ जाएगा M30 है तो हो सकता है वो आ जाएगा M43 या M40 भी आ जाए. तब उसके लिए डिजाइन होगा टारगेट मीन स्ट्रेंथ. टारगेट मीन स्ट्रेंथ, अब उसके अनुसार आपको क्या करना है, अप्रूवल देना है. अंशुमन जी को अब अप्रूवल देना है. अब सारा चीज इनके पास आ गया. व्हाट विल ही डू, तो ही विल इन हिज सुपरविजन ही विल make a trial mix again with those ingredients in those proportions. Okay, there is a hand mixer in lab, then everything is to be weighed, placed, and water in same ratio, plasticizer in same ratio, even mineral and mixer, fly ash in same ratio. Cube has to be prepared at least, 9 to I think 15 cubes, I don't remember, and that is to be subjected to test in lab. And when the lab results comes, target mean strength minus 3.5 MPa, then only cube can be improved. It's not that FCK has been achieved, no, because FCK, if it is achieved in lab, what will happen in the field? It will come down drastically. So that's why target mean strength is higher than FCK. So suppose ideal, if we aim at the sky, we can at least reach the height of a tree. So our aim should be higher. Got the point? So then if that is satisfied, he will approve it. Okay, then it will be decided, and that blending ratio has to be maintained until and unless there is a drastic change of source of material. Even source of material may lead to some changes. Okay, so this is very important. With each lot of material you have to source of raw material. Not with source. Suppose source is of this query. So if it is coming, it's okay. If you notice some drastic change in the query itself, some it is coming from Chutupallu query, then you can get a check also. Okay, but human errors like this has to be eliminated. What I have told you, that triplicate Chalan method and those methods, these human errors, they don't do it deliberately. Sometimes engineers don't do it deliberately, even contractors, engineers, but ultimately human error should be paid attention to and they should be eliminated. Maintenance management. Okay, so what strength would be achieved? Target based strength or characteristic strength? No, you are talking about trial mix or working concrete? And we take one book. Then what say target based strength or no. FCK plus 3 MPa. mean of all 4 samples. That 4 samples has to be tested. So FCK plus 3 MPa for 4 samples. If mean is FCK plus 3 MPa, okay. Then, but individual samples should not be FCK minus 3 MPa. When these 2 conditions are satisfied, then only say acceptance criteria. अभी तो मैंने बताया था. कुंदन जी, आप सो रहे हैं क्या थोड़ा? कहाँ गया? Mean strength determined from any 4 samples should be exceed the compression by FCK plus 3 MPa और individual sample FCK minus 3 MPa. हो गया ना? तब ये सेटिस्फाई नहीं होता है, तब कंप्लीट फेल कर रहा है, तब कोर कटर पे आपको जाना होगा. और कोर कटर भी सेटिस्फाई नहीं कर रहा है, तब फुल कटिंग. So maintenance of everything, breezes तो है ही, लेकिन it includes everything. So I had written one article in IRC journal in midterm council when it was held. My topic was maintenance of breezes itself. So I couldn't bring that. That was a very elaborative article. But since time is less, so I will elaborate 3 points. Bridges are the most vital links of connectivity in the network of transportation. Most vital links. Because if anything happens with bridges, then there is a disruption in traffic. But often, the most vital link of connectivity is the most neglected one in the maintenance network, in the maintenance man, isn't it? Do you agree? Huh? Yes, yes. So the most vital link gets the most neglected in maintenance budget also. There is no priority for that. So since this is the most vital link of connectivity, it should be paid more. If something goes wrong with the road, you can repair it instantly with GSP or something like that, or even bituminous course. But what will happen to the bridge? Then you repair it very instantly. If the bridge collapses, no. So maintenance is very important. Now, why maintenance is important? I have said in many lectures that asset maintenance is of far more important significance that asset creation. Asset creation से ज़्यादा important asset maintenance का. How? Suppose you have got 5 houses and none of them is maintained. You don't have any house at all. But if you have got only one house, and if that is well maintained, at least you have got one house. So whatever asset has been created, the first priority of engineers should be asset maintenance of all those created assets. Do you agree or not? Do you agree? That's why maintenance is very important. Now, when does the maintenance start? Maintenance and repair both are different things. So maintenance starts from the very next day after completion of the project. A child's maintenance starts the moment he is born. Just like this is your baby, the asset you have created. So it starts the moment it has been created. So first comes the routine maintenance. So I was. What should be for the concrete structure? What should be minimum aggregate value for the concrete structure? Just in the we are on the path. No, that is different for different. Was concrete? No. Yeah, actually for road it is 27 AIV or 30 AIV. But concrete, even 40 AIV is okay. Then we check the gap and we get can value 30 or 30. Okay. For concreting it is okay, but not but for the bearing code it should be 27. But apart from aggregate impact value, you have to check the angularity of also. Angularity of it should be angular, not rounded. Because rounded aggregates, they don't do overlocking. Now, this is the importance of maintenance of bridges. Maintenance of everything. Maintenance of your building, maintenance of your house, maintenance of your office. So if it is regularly maintained, then if it is not maintained, then it gets damaged. Then comes repair. If it is not repaired, then it gets distress beyond the hope of repair. Then it comes rehabilitation. So maintenance, repair, rehabilitation sequence. So daily, what are daily maintenance activities? You know, objective is clear: ensure long-term uninterrupted service, ensure structural safety, ensure safety of the bridge users. So in case of building, it's the building users. So if it is well maintained, building will be safe. It will be safe for the building user also. Long-term durability. Now, inspection can be regular routine inspection, then detailed inspection and special inspection. Regular routine means you can carry out 2 to 3 times a year, one well before monsoon. So what you have to see during routine inspection? Suppose I am going there, we have to make a chart. What are the things we have to see in routine inspection? The first and the foremost is the drainage spot. So that is a matter of routine inspection. Even if you build the bridge to the best quality, the drainage spot is likely to be choked. How? Because aggregates, mud keeps on falling on the road and they get swept away to the side. Okay. So anything which falls on the road during transportation or even wind comes on the road, and by uh, wind force generated by the flying vehicles, they get swept away to the side and they get deposited in the between the curb and the wearing coat in that area. So that is called graffiti or debris. That blocks the, and that will lead to the vegetation growth by the side of the bridge. So that will block the drainage. So if drainage is blocked, then wearing coat gets damaged. If wearing coat is damaged, then there will be potholes. If potholes are there, then vehicle will get impact loading on the bridge. They will, it will be like a roller coaster ride. Then that will damage the bridge. So one small thing will lead to the damage of the bridge. So first, notice the drainage condition of the bridge. If there is a debris or graffiti on the side of the curb, get it removed, vegetation removed, clear the all drainage spots so that the drainage is okay. And not only there, drainage everywhere, even approach road. Okay, then just have a look at the bearings or uh, protective works and all those things. Then railing also. And if railing is damaged, somebody may jump off the bridge and may fall on the river side. Then crash barrier. Then hazard markers. So bridge has got two faces, one left and right. So during night, what happens sometimes people are not able to recognize whether bridge is this side or that side. So they go off the road. So hazard marker, there is a red and white painting or black and yellow painting, and arrow should be indicated. This is bridge side. So people will not follow the road. So all damaged hazard markers, and when painting, if the painting is not conspicuous, railing painting, it has got faded away. Then that, so these things come under the routine space. That's like building also. So go to the terrace, see whether the drainage the spot is functional or not before the monsoon. If it is not, if it is choked, then see the slope of the roof. Everything is like that only. Then wearing coat. Sometimes wearing coat damaged, and when somebody told, then they keep on putting overlay, increasing the dead load, which is very dangerous thing. Not only dangerous for the but this is dangerous because what will you do at the expansion joint? So you will put a cover near expansion joint and that gap will enlarge because steel cannot take this bituminous wearing coat. So that is very dangerous. So it is better to scrap or by milling method or again relay it. Okay. So if wearing coat is not proper or damaged, potholes are there, then vehicles will create additional impact loading on the bridge. And if overloading vehicles keep on hammering the bridge, then bearings will get damaged. Okay. So these are the routine inspection. Detailed inspection you can carry out anytime, but routine inspection has to be carried out regularly in any work, even in your house. Okay. So if you take the curative or remedial measure in time, a stitch, we know one proverb, a stitch in time saves nine. But if it is neglected, everything will become out of control, be it your house, be it your building, be it the bridge, be it road, everything. So my importance is always on maintenance side. Asset maintenance is far more important than asset creation. Do you agree with this? So what are the components to be inspected in bridge? Accordingly, you can correlate with your components of your department. So bridge deck, bearing port, bridge parapets, railings, approach slabs, approach roads, underside of the bridge, bearings, pedestals, piers, abutments, masonry work, if any, section work, visible foundation, top components, drainage. These are the things you should do. What are the equipments for detailed inspection? For routine inspection, you can do a visual inspection. For detailed inspection and special inspection, binoculars and telescope. So from distance, you can see the bearing. Okay, it is disclosed or not. So you need not go and see there. You can record. Okay. So every engineer, bridge inspecting engineer should have a binocular or telescope, small telescope, or binocular, measuring tape, adjustable ladders. It's required sometimes. Suppose you have to climb on the top of the pier, then measuring tape, always it has to be there. Leveling instrument, so that you can see the level of the deck, whether sagging is there or not. The level at the end, at the pier, and at the middle. So you can see the difference. If it is sagging is excessive, then the bridge is going to collapse. Because if there is excessive sagging, what will happen? The top profile will be concave like this, and all vehicles will go on impact loading like this. They will create additional impact loading. So this is very important. Now, rebound hammer, Arif, you know it. So that is only for indicative test, whether concrete is porous or something like that, something has happened. So rebound hammer will give the strength. Then acoustic crack detector. Acoustic crack detector is a detector which gives the depth of the crack. So whether crack is superficial or structural, you can. Then magnetic detector. Magnetic detector gives the position of the reinforcement and whether cover is has become eroded or whether cover is going to be exposed. So then mechanical extensometer. Mechanical extensometer is a sort of thing. Suppose it is a transparent sort of thing in which you paste on the expansion joint. You can notice the variation in the gap. So you can see. So expansion joint is also a very good indicator of what's happening with the bridge. It also indicates the health of the bridge. So suppose it is going on expanding. So somewhere something is happening below. Okay. So from there, it gives an indication like fever. If there is a fever, you know something is happening, some inflammation is there in the body. So then electric resistance meter, ultra pulsonic pulse velocity equipment. अरे ये कहाँ से चला गया? छोटा कैसे हो गया? So ultrasonic pulse, if there is any cavity inside the body of the concrete, that will be detected by ultra pulse. So before launching the gutter, you can check it. Suppose concreting has been done and there's some pocket. So ultrasonic pulse velocity, the velocity density of the concrete is high, then velocity will be high. The concrete is porous, then speed of the ultrasonic pulse velocity will be low. So that if the speed is from this side to this side is lower than the standard one, then that means there is some porosity and cavity. So that can be rectified by taking some grouting method and grouting method. Then plumb bob to check the verticality if there is got inclined or not. So plumb bob can be used. Then ranging rod for checking the straightness in the river bed also. So where all the piers are in the same alignment or it has tilted laterally. Okay, verticality can be checked by the plumb bob. But what about lateral? So keep the ranging rod with a reference to the abutment and see through the telescope or your leveling instrument. So these are you can. Huh? Yes, yes, why not? So after inspection, prepare a detailed inspection report in a standard format. So there is very standard, many standard formats in the book also. In the book of one written by Mr. Ponnu Swami, bridge engineering of railway side. So there is a very standard nowadays standard formats are available. How to record your this one? Then this is the real part, carrying out maintenance works. So this is also a very vast subject. Someone was asking about spalling, so it will come. First is cleaning and drainage, repair of damages, crack repair through epoxy injection. अगर crack repair है, it can be repaired through epoxy. Minor crack है तो, or it can be through cement grouting, pressure cement grouting. Then cement repair surface with polymer modified mortar. Suppose there is a loss of concrete. Suppose concrete has got worn off from the surface. So if it is superficial, then it can be done through polymer modified mortar or goniting of, if suppose the area is large, then short creating and pressure gun, goniting. So high pressure is given and it is pressed, and with compressed air, it goes and it gets deposited there. So then corrosion removal and corrosion protection. So spalling. Spalling is nothing but uh, concrete falling from the underside of the slab or beam, and it often happens because of the weak concrete cover or reinforcement in the corrosion in the reinforcement. Because during corrosion, that expands because of ferric oxide, and that expansion leads to the detachment of concrete from below. It starts falling. It may happen in your house also, in building also, in bridge also. But if the cover of the concrete is very strong and very okay, up to 50 mm for beam, 25 mm for slab, building slab, isn't it? So if that is dense, that is well compacted, then corrosion will not take place because there is no honeycombing also. So there is no chance of ingress of water and air. So if there is a spalling, first thing is that you remove the corrosion through anti-corrosion treatment with brush. Corrosion has to be removed. Then there is a another coating of bonding agent. Whatever fresh thing or concrete is to be applied, that has to stick with the old one. So Nito bond is there. Then there is one, latex SR60 or 360. Various compounds of bonding agent have come. Then concrete can be rebuilt also. Epoxy patching can be done. Okay. Then concrete of high grade or polymer modified concrete can be also patched there. Okay. But vertical, horizontal support sometimes has to be given for some period. Otherwise, when you just leave it there, it may fall down. Then corrosion, then maintenance and replacement of expansion joints and bearings. So if expansion joints get damaged, those are to be replaced. Sometimes bearing get damaged. So if it is damaged beyond the hope of any repairing, then it has to be replaced in time, because sometimes pedestals and uh, faulty expansion joints, faulty bearings, they lead to the collapse of the bridge. It has happened in many parts of the country because no one noticed it. It suddenly got dislodged, the expand dislodged from the this one, and sometimes the pedestal got crushed until impact loading. Then maintenance, this one, wearing coat maintenance and replacement. I told you, if the wearing coat gets damaged and if that damage is very high, then it will also lead to the damage of the slab. So this is to be replaced. Then foundation substructure repair. Foundation and substructure, then protection works repair, strengthening and retrofitting components through jacketing, fiber enforced polymer, wrapping steel, plate bonding. These are even external stressing. Suppose there is sagging. So a system has come by doing external stressing outside the beam from bottom. You can do the sag correction. So external stressing. Then jacketing, which is being done in some of the bridges in Jharkhand also. I think there is one bridge in Bokaro which is undergoing rehabilitation, whether jacketing is done. So if the foundation concrete or soft concrete or pile cap concrete gets exposed, or even the top pile concrete gets damaged, loss of concrete, then a jacket of concrete is given with and strengthening is done by injecting nickels, pressure grouting, so that porous pile which is at the top can be strengthened. So that is has been undertaken in Bokaro division, because I was in contact with the agency. He came to me and he referred the problem and we discussed it. So uh, jacketing, external press testing, conical. So these are every uh, uh, topic will take at least half an hour to understand. So I am giving an overview, but when you know the topic, you can learn about it. Okay. So when you know jacketing, so when you search, you will get what is jacketing. When you underpinning, then external pre-stressing, Then repair of spalling and delamination. So that spalling is also called delamination. Okay, in masonry bridges, there is a phenomenon called leaching of mortar. So then protective jacketing in damaged substructure and foundation, underpinning in damaged foundation. So underpinning is strengthening the bottom of the foundation by several methods. So that comes under underpinning. Oh, so as per slide, uh, it has come to the end. If you want to learn some more things, I can carry on.